All right, let's take a look at taking the derivative of some of these functions. So if we started off with, y is equal to 3x plus 5, then we can actually just take the derivative of each term on its own. So then we can say y prime, or the derivative of y, is equal to, and then we just have to follow that simple derivative rule, right? So it's right now this is to the power of 1, right? And then we bring that down and then subtract 1. So this would all become 3 times x to the power of 0, right? Plus. And then the derivative of any constant term is just 0. So we don't have to worry about that. So now y prime is equal to, and then x to the power of 0, well, that's just 1, right? So this becomes just 3. Now, let's just take a second to think about that too, right? Because the derivative is the slope of the line, but we were actually dealing with a straight line, weren't we? This is 3x plus 5, maybe something like that, right? This makes sense. The derivative doesn't even have like a variable in it because it's just always 3, right? Because the original function was like this. So the slope of this line everywhere was 3. That's exactly what we expected. From y is equal to mx plus b, we knew it was going to be 3 anyway, right? So just so that makes sense with our intuitions. I just want to make sure. All right, so now let's look at the next one. So now g of x is equal to 5x squared minus 3x minus 2. Okay, so we're just going to do each term individually now, right? So then g prime of x, or the derivative of g of x, is equal to, so now the 2 comes down, so this becomes 2 times 5, so 10x, and then the power is 2 minus 1, so 1. Okay, and then moving on, minus, now we got 3 there, right? The derivative comes down, so this just becomes 3, because it'll be x to the 0, kind of like the one we had above, right? And then that's it. Like I don't have to write minus 0 or anything. That is my equation for the derivative. All right, moving on. So now the next one here. So sometimes these ones just take a little bit of an initial setup. So we have h of x is equal to 6 over x to the 8. All right, so now how does this work? We've got a fraction involved here, right? Well, what we're going to do is we're just going to rewrite this thing without the fraction. So this would be the same as 6 times x to the power of, and then if I want to bring this guy up to the numerator, then I'm going to say this is to the negative 8. And now we can just use our rule, like with the negative and all. So let's say h prime of x, or the derivative of h of x, is equal to, now let's stick to our rule. So the negative 8 comes down, okay? So then when it comes down, it gets multiplied by the 6. So we've got negative 48x. And now just careful on these ones, right? Because we're in the negative, and then we're subtracting 1. So it's actually going to get more negative. So we've got negative 8 minus 1. This actually becomes negative 9. So the power of negative 9. So that's correct. We could also write our answer as negative 48 over x to the power of 9. And just get rid of the negative on the exponent there. All right, last one. I'll write it over here. So f of x is equal to the cube root of x to the power of 2. So squared. All right, so now we haven't dealt with fractions, right? So what we have to do now is just rewrite this radical as a fractional exponent. So this would be the same thing as x, and then the power is the top part of the fraction, and the index is the bottom part, so it's going to be over 3. So there we go. So now we can say, okay, the derivative of x is equal to, the 2 over 3 is going to come down, so I've got 2 over 3 x, and now we just have a fraction to deal with there, right? Which we're going to have to kind of get used to. So we've got 2 over, so make sure you guys get this. So 2 over 3, and we're going minus 1, okay? What you should start doing, just so you can do these things a little bit more quickly in your mind, is as soon as you see like that minus 1, because it's going to be so common, think 3 over 3, right? Because that's what we know 1 is. So just right off the bat, you could probably do this in your mind. You could say, okay, 2 minus 3 is negative 1 over 3. So this is to the power of negative 1 over 3. Okay, this is perfectly fine, right, to leave it this way, but we might write it a few other ways. Maybe, so with this negative exponent that we have now, this would be the same thing as, well, the 2 up in the numerator, right? And then since our x is to a negative exponent, this would be the same thing as, well, having the 3 down there, but now x to the power of 1 over 3 in the denominator. Okay? And maybe we want to write it as a radical again. So then we can say this is 2 over 3, and then 1 over 3, so that would be the cube root. So that would be the same thing as the cube root of x.